So an ellipse was a set of points so that the sum of distances was the same. A hyperbola is the sum of points where the difference, the subtraction of the points, is the same as a constant. This is a general hyperbola graph. Okay, it just kind of gives you all the things for a sideways orientation. Just like how ellipses could be going side to side or up top to bottom, hyperbolas can point to either side, or they can point top to bottom. A is still the distance from the center to the focus. B is still the distance from the center to center to vertex over here. The distance from the center to the vertex is A. Distance from the center to the co-vertex is B. I'm not actually allowed to use that term co-vertex because this point isn't actually on the graph. The green line is the actual hyperbola itself. Everything else is just stuff you find to build the hyperbola. So it's not technically a co-vertex, but you can think about it the same way. These two lines here are asymptotes. Lines that the graph gets closer and closer and closer to, but never touches. This is our big page of formulas and equations and info.
So it's the same one that was on my answer?
That was at the end of class yesterday. Yes. Because the difference is hyperbolas have a plus here. Ellipses have a plus here. Hyperbolas have a minus. For both. These are both hyperbolas because they both have minuses in between. And you'll notice that they use the good Pythagorean theorem, not the evil one. It's actually just regular a squared plus b squared equals c squared. So I always remember, whatever sign goes in between here, there's an opposite sign goes in between there. The biggest difference between hyperbolas and ellipses in terms of their equation, with an ellipse, a was always the biggest number, and with hyperbola, that's not the case. Okay? With hyperbola, a is not always the biggest number. But we'll see how it works in a second. You still have vertices. I'm using the term co-vertices. There's still foci with the c value. They don't call it major axis and minor axis, called the transverse axis and the conjugate. Doesn't really matter. And now there's asymptotes, and the asymptotes have very simple equations. Plus or minus b over ax, or plus or minus a over bx. Yeah?
What's the difference between those two?
Between what two?
The two columns.
One of them
Does one of them go up and down?
One side to side, one's up and down. Thanks for asking. Horizontal is the one that's going this way. Things are pointing horizontally. Vertical is the one going this way. Here's what I wish I'd done the last 3 times we did this. I apologize, I forgot that I had this option. I'm going to graph over here on the left. You can keep looking at stuff on the right if you want to. Yeah, sorry I didn't do that last time. I
That's amazing.
forgot all about it. Forgotten more about smart boards than you'll ever know. Okay, here's my equation. Because, yes, Natalie?
Can papers be like diagonal so it's not like horizontal or?
They can, and we're not going to do those, but they can. Because the x is coming first, that's what matters here with hyperbolas. Because the x is coming first, just like it did over here, we know this one's going to go side to side. It's not because 9 is bigger than 4. It is bigger than 4, but that's not why. We know it's going side to side because the x is coming first. My a value, well, if a squared is 9, then a is 3. And if b squared is 4, then b is 2. And from the center, my a value is going to send me left and right 3. So there's a vertex, and there's a vertex. That's my a value. The a value sent me left and right 3.
Is there no up and down to the a value there?
Well, the up and down is going to be the b value.
Oh, okay, so then it's going to move the vertex up too.
Well, no. From the center, I'm going to go up 2 and down 2. And those are kind of like my co-vertices.
Okay.
Just hang on, we'll see what happens here. All right, some green. B squared equals 4, so b equals 2. A squared equals 9, so a equals 3.
So you kind of like build it as if it's gonna be an ellipse, but then you don't draw it as an
Yeah, so they honestly have very, very similar structure with how you put it together. But the hyperbola has one really big difference. With the hyperbola, I'm going to draw a box that covers all four of these points, all four of these outside points. I'm going to draw this box right here. Like that. And I'm going to connect the corners of those boxes. So I'm going to make asymptotes by connecting the corners of those boxes.
Like the opposite corner?
Like this. There's one of my asymptotes. Work? That should work, huh? And there's the other. Nope. I'm gonna try that again. There's the other. Then, from the vertex, not the co-vertex, the vertex, I'm going to draw a curve that gets closer and closer to the asymptote.
Oh, that's it.
That's it.
Do we need to clear any points, or can we just do
What
that?
about the foci?
I'll find the foci in a second. But for the actual drawing of the hyperbola, that's the process. Yeah?
And why do you need the foci? Does it help you draw?
It doesn't help you draw it, but the foci is kind of the point if you're ever actually working with a hyperbola or an ellipse or a parabola. Okay? Because what I forgot to mention from before, I'll do it here. If I have, remember how with the parabola collects everything and sends it to the focus? Like if you pointed at a satellite, everything coming from the satellite will get reflected to one spot. You can interpret that. Well, the hyperbola has a similar but different property to it. With the hyperbola, if I draw a line that's going straight to this focus over here, I haven't graphed the focus yet. But if I draw a line going to the other focus, when it hits this point of the hyperbola, it's going to bounce to this focus. You can gather everything that's pointed to a general area and put it in one spot. That's why you want the focus. It's useful for something. So let me find the focus first.
I guess just my question was, when it's horizontal like that, it's always going to be on the x-axis. It won't move up and down at all.
Correct.
And when it's vertical, it's only going to be on the y. If that makes sense.
Right. It can move side to side, but we're not going to. Okay, I'm always going to have our center be here. Always at the origin. So let's find the foci. To find the foci, I do the good Pythagorean theorem, which is 9 plus 4 equals c squared, which means that 13 equals c squared, which means that like 3.5 equals c. So I go right 3.5, and I go left 3.5, and those are my foci, those blue dots. That's a focus, and that's a focus, that's a vertex, and that's a vertex.
Will the foci always be out of the...
Yes, the foci on every single thing we do, the focus is always kind of inside the curve. Wherever the curve is, the focus is always inside it. What's the equation of the asymptotes? Good start.
Equals plus or minus 2 over 3.
Yeah, we're doing this one here, and b is 2. So this one's 2 over 3x, and this one's negative 2 over 3x. They're just opposites. They're not reciprocals, they're not perpendicular, they're just opposites.
Would it ever be perpendicular?
Unless it was a right angle inside there. That would mean the a values were the same, and that would mean it was a circle. So only if it's a circle.
What about transverse, not conjugate?
That's just, transverse just means major axis. That's the transverse. Conjugate just means minor axis, basically. That's the conjugate. I'm not going to worry about it.
Not there, it is.
Other questions? Okay, let's do a couple more. it makes everything half as big, so I had to draw everything twice as big, so when I went split screen, it would be half. We're going to write the equation of this hyperbola. All the hyperbolas we do will be centered at 0, 0. Okay, I'm not going to move them around. I'll move around ellipses, I'll move around circles and parabolas, but not hyperbolas. What do I know? In fact, turn to your friend and tell your friend what you know about this hyperbola. Anything at all. Anything about the equation, whatever. Okay, what do we have? Yeah, Lindsay?
Well, you know it's vertical,
We know it's a vertical orientation.
so you know that you're going to have y squared over a squared minus x squared over b squared equals 1.
Always equal to 1. Good.
Then you know.
Let's spread them off a little bit.
Oh.
Yes, Caesar?
It would be y squared over 16. X squared over.
How'd you get the 16?
Because the vertex on the vertex is 4, -4, so x squared is 16.
So that's a length of 4, so that's a. So a squared is 16. Good. Same thing for b. This over here is a length of 2. That's our b value. b equals 2. So b squared is 4. And that's the equation of the hyperbola. Yeah?
Is A, you said that A is not always the longer one? So how do you know which one's A and which one's B?
A is whichever one comes first. A always comes underneath whichever one's coming first.
But like on the,
Yeah. Because it was a vertical orientation, A was the vertical one. Had it been a horizontal orientation, A would be the horizontal one. Yeah, Chase?
The asymptote equation.
Good, thank you.
2 and -2.
It might be. Let's see. For the asymptotes, it's going to be y equals plus or minus, and this is going to be a over b, b over a. Let's check that real quick.
Oh, that would be.
It is over b.
A over b, it's this one right here, because we're doing vertical. So it's plus or minus a over b, which is going to be
4
4 over 2, which is 2. So it's y equals plus or minus 2x. Those are the two asymptotes.
When we're asked to write the equation, do we have to find the asymptote equation as well?
It'll ask for it, yes. I'll ask you for the asymptotes.
Okay.
I'm giving you the formula for it. Everything on this sheet will be given to you on tests and quizzes and your final. Let's do foci also. How am I going to find the foci?
A and B.
So I have c squared equals the good Pythag. So c squared equals 16 plus 4. So c squared equals 20. What's the square root of 20? Does anybody know?
4.45.
4.4. 4.5.
4.5.
You just go 4.5. I said wait. Yeah?
Wouldn't the a and b be 4 and 2?
But it's a squared.
Oh,
A is 4, but a squared is 16.
yeah.
So 4.5 is about here, and about here. Nope, sorry, about there. Those are my foci. We haven't really done this much yet. We've done it like once or twice, but I want you to actually give the coordinates. Like I want you to say, this is the point 0, 4.5. That's the point of that focus. This is the point 0, -4.5. Question there? Okay, I want you to look at this right now and keep your eyes on it when I switch the page. Look at this, and I'm going to switch the page. I kept the exact same box and the exact same asymptotes, but I went from a vertical orientation to a horizontal one. So it's now x squared over y, x squared over a squared, minus y squared over b squared. X now comes first because it's horizontal. The a value is now this 2. So it's now x squared over 4. The b value is now this 4. Y squared over 16. And that equals 1. Just switched. Foci is still going to be 4.5. That's not going to change. 1, 2, 3, 4.5. 1, 2, 3, 4.5. Those are still my foci, just now they're over here. And from there, we could, the asymptotes are still plus or minus 2x. And that's that.
If you go back, like, what flip for what flip for the x and the...
Yeah, all that happened was it was this, or is this now,
Right.
coming from
Okay, so
that
it's the
there.
x and y
There's
squares.
the y.
Move the foci to the x-axis. That's it.
Mhm. Question there at all? Yeah.
So, you said that if it's a vertical box, then it's
Y comes first.
and A is what's vertical, right?
Uh-huh.
But it looks like you switched A and B.
Well, I switched what A is. Last time A was the vertical one. This time I have a horizontal orientation, so now A is the horizontal one.
But how do you know it's horizontal?
It doesn't actually matter in this case, okay? A and B don't actually matter with hyperbolas. What matters is whatever's underneath the x variable, that's the one that sent you from side to side. Okay? So since 2 was my distance from side to side, I did 2 squared to get 4.
Oh, well, that makes sense.
And that's also how it is with ellipses, really. You just have to think about major minor. It's kind of it's really the same idea.
A is like parallel to the x-axis,
But not always. So don't think about A, think about the variable x. X is the one going side to side. So the number corresponding to x, the number underneath it, is the one going side to side. So if I drew, anything right now, if I did like this. I don't care what A is or what B is. It makes no difference to me. I just know that from wherever my center is, I'm going to go left 5 and right 5. Because that number underneath the x squared is 25, which is 5 squared. I'm going to go up and down 10. Even though I never took the time to figure which one's A, which one's B. I don't know. I don't care. I'm just going to go left and right 5, up and down 10. And since the x came first, this one's going to graph kind of like this. Because the x came first. That should cover you for hyperbolas today. I want to go through a completing the square example real quick. When you're completing the square, get the x's together and get the y's together. And I'm going to move that over. So I have 9x squared plus 72x plus 25y squared minus 150y. And that equals negative 144. And move that 144 over. Before you try and do your b over 2 squared, factor. Factor this first. Now, my b value is 8, so b over 2 is 4, so b over 2 is 16. B over 2 squared is 16, so I put a plus 16 here. But it was really 9 times 16. It was really 9 times 16. I don't worry about that inside the parentheses. Over here on the left, I just put the 16. Here on the right side, it's 9 times 16. For the purple one, I'm going to factor out a 25 and that leaves me a 6. And my b is -6, so b over 2 is -3, b over 2 squared is 9. So I'm adding a 25 times 9. So the left side factors into this. The middle piece is gonna give me this. It was. I'm doing it on purpose for that reason. And it's equal to this. I just did that and that and that, and I know it equals that.
Oh, negative.
Oh,
225, not 255.
yeah, that's what I was thinking.
225.
Why did you times 25 by 9?
Because
I put a 9 here, but it was times that
Oh,
25.
you're just confused because the 9's outside the 9 and the 9's inside.
Yeah, there's 2 9s. Get over it, Annabelle.
I'm not just confused.
Get over it.
Over it.
Divide everything by 225. Because this has to equal 1. And this reduces into x plus 4 squared over 16 plus y minus 3 squared over 9 equals 1. And what a pretty ellipse that is.
Oh, that makes so much more sense.
What a very pretty ellipse we have.
B over 2 squared of
Is that recorded?
-50.
It's recorded. That's why I raced through it. I know I went quickly, but it's online, so you can look at it at the end now.
So we can hear our voices?
You can hear your voice, you can hear me saying, come on, Annabelle, pull it together.
What?
But there's 2 9s! How can I ever deal with 2 9s?
So, it's still fine.
Well,